Hello, this is simply about networking protocols, and today we are talking about routing table or FIB, and routes. Basic standard for the routing is RFC 1812. There are much more standards that describe specific protocols or specific networking functions. All of them are based on this 1812 standard. So, for IP communication to happen, we should have IP interfaces, L3 interfaces of model OSI. IP interfaces, as I mentioned already in the video related to interfaces, interface can be IP interface is if IP address is assigned to it. Well, obvious. Important note: on neighboring devices, connected interfaces should have IP addresses in same subnet to allow the communication using IP protocol. This is the must. Well, those interfaces are, from system point of view, pretty same as a port, only virtual. So we can imagine that from system point of view, it looks like that. And then middle device has routing table with number of routes to the neighboring devices. To the left device, it has only one route to IP 12, 13, 14, 15. To the right device, it has 3 routes to different subnet. Yes, it is possible that one device is identified with multiple IPs. By the way, this is why in RP table relation is many to one, because device has only one MAC but multiple IPs, or multiple MACs then one-to-one. Whatever. About RP we will talk separately. Routing table, this is an universal tool because we can imagine that all devices are the routing tables with routes to neighboring devices in this case, and they are notifying the system that IP frames in some specific subnet should be sent to next device with some specific IP for processing. Well, if we don't know what else to do with this IP frame. But in case of routing, we know that this frame is not destined to us. It should be somehow routed further. More than that, left device, well, not the left device, but we know that left device can send traffic to right device through the middle one. And on left device, we can add routes to the right device through the middle one, 12, 13, 14, 155. This is the IP of the interface in this subnet on the middle device. And we expect that middle device knows what to do with those frames further. And it actually knows because those are connected routes. If those routes through the middle device to the right one were added by administrator using some UI, those are static routes. If they were added as a result of work of dynamic routing protocols, those are dynamic routes. My congratulations, you now learn what is static routing, what is dynamic routing. That simple. So dynamic routing only notifies that routing table was filled by some dynamic protocols. That's it. More than that, if we know that behind right device there are some more devices in different subnets, we can specify those subnets and routes to them through the middle device, right device, or whatever, on all lengths of the on all lengths of paths to those devices. Actually, from administrator point of view, this is a little bit overwhelming to running around and looking for the possible subnets and entering all those data into every routing table on every router. This is why dynamic routing protocols are so popular. They doing 99% of the job. Well, if we take a look on possible paths from the right device to the left device, it is also going through the middle device, but here we have three possible routes, three possible channels to transmit traffic. So in the routing table, we have three possibilities that everything to 12, 13, 14 sent here, here, or here. Those channels, those routes, those paths can differ basing on the power of the channel, or basing on the line rate of the channel, or channels basing on the number of devices between source and destination, and many other parameters. Dynamic protocols calculating this automatically. Administrator will have to do it by hands, while in different after different calculations and so on, we can get the cost of the transmitting traffic by one of those channels, by one of the selected paths. In case some path is much better than others, we can use this path and ignore others, and leave only single route. In case we decided that those passes are equal and we expect that single channel can be overloaded, at some point we supposed to transmit much more traffic than one channel can do, and we need multiple channels, then we can use all the passes combined into ECMP group. My congratulations, you just learned what ECMP is. ECMP group, or equal cost multipath group, this is group of the routes that have similar cost, and system can balance traffic and send part of the traffic by each of the route. Visually, we can explain it like that. This is some balancer that, using specific algorithms, selecting basing on the values in the frame fields, to which path send specific packet. Then each channel is loaded not that completely, not that high. Traffic is running, at some point is combined back and sent to the destination. This could be not clear why this is required, because this schema is too small. Okay, we can expand it and display like that. In case, for example, 3 servers need to communicate to one, and they send in traffic, and this traffic will definitely overload single channel somewhere in between, we can add a balancer and a ECMP group that will balance traffic using different routes from the router. Traffic runs by those routes. At some point it combines and goes to the server. Again, this schema is used only to present the possible scale, but all the verification of this functionality can be done using single device. Different configurations in some configurations, different types of traffic, and so on and so forth. So this complication is not necessary in case you are trying to verify that ECMP is working correctly. And now let's talk about selection of the route. Well, routing table contains huge amount of possible routes, and we need to pick one where to send, which to use to send our packet. This is done by comparing subnet. To remind yourself what is subnet, how it is calculated, check video with MAC and IP addressing. There you also will understand why subnet 900/6 is a valid subnet for our destination IP. But if we have IP and subnet that are matching, and this is only one entry, we're using this entry, no big deal. When we have two potential entries, then, or even three potential entries, then we selecting entry with longest mask, subnet mask. This rule is mandatory for selecting path in the routing table, because it is expected that the shorter mask, the bigger section of networks and subnets it covers. It means that final destination can be far, far, far away from our device on this path, because there is huge amount of networks and subnets. But when we see subnet /24, then this particular subnet, that is part of that one, by the way. No. Yes. This subnet is part of this subnet. But it means that this subnet connected somewhere closer to us than if we send it to here. So standard rule, the longer the longer subnet mask in the entry, then we select this entry. Very simple. And default route, if we have no entries that matching our mask and we have default route configured, we're using it. If we have no default route configured, this packet will be dropped because we don't know where to send it. That simple. Thank you. Have a great day.